Thank you everyone for joining us today on another SDX Central webinar. Today we'll be talking about a pragmatic approach to achieving programmable network automation. And we have joining us today, Chris Wade from Itential as well. He's the co-founder and CTO, and Chris has been working on network automation and orchestration for a long time now and has a lot of experience in it. In today's webinar, we'll talk a little about how we got here in the first place, and then we'll dig right into how we are able to use existing tools that you may have to put together an effective strategy for network automation. In fact, you'll be able to figure out how to identify and catalog all the existing network solutions you have in place today, how you can actually put in an approach that can provide you with ROI in a very short time, and how to use proven strategies that we've seen succeed in other enterprises and service providers, and use those strategies to phase in a reasonable and pragmatic network automation approach. And if you have any interest in improving your network visibility, scalability, configurability across the board, this webinar certainly is for you. Now, what we'll do today is go back and forth a bit between Chris and me. And there's a lot of topics to cover, but I think we'll be able to do that pretty effectively in the next 15 minutes or so. We'll start out talking a bit about the state of networking, where SDN has taken us. We'll talk about the potential for network automation and what analysts and other pundits view as the potential for network automation. And then we'll get right to it and talk about how we go about taking a pragmatic approach to automation. Chris will give us details around use cases and customer stories that they've seen, and then talk about next steps and the evolution of network automation. So with that, let's go ahead and get started. Now, how did we get here? Those of you who've been with us at SDX Central for some time will probably remember when we were touting SDN, and not just us, but pretty much the whole industry, SDN, NFV, and what it was going to do to change the whole industry, and how it was going to be groundbreaking and revolutionary in many, many cases. There were some more reasonable voices that suggested that it was more likely to be an evolution. But regardless, the full promise of SDN and NFV have not really been fulfilled. And so what we've seen is that due to various reasons, right, whether it was an inconsistency in the way that vendors implemented SDN, in some cases the standards came along, but they weren't sufficient, or they were not sufficiently detailed, and different vendors implemented them differently. There were situations where you were trying to do implementation, but not all the equipment you were working with was SDN capable. And in many cases, what we found was there was actually more complexity, even though SDN promised more simplicity than we expected. And the other thing that I think we all collectively learned, and enterprises and service providers alike learned, was that there was a lack of expertise, and it wasn't that easy. If you were familiar with network architecture and command line interfaces, it wasn't that easy to turn everyone into a programmer. And there was a lack of expertise, lack of awareness, and in many cases, lack of the right culture. Now, despite those challenges, SDN and NFV are core to most of the orchestration solutions out there today, data center network virtualization platforms, and the ever popular SDWAN. All of these use SDN principles. And so the principles have lived on, but maybe the full extent of the promises were not fulfilled. And so, in some cases, you could call it a market correction. And so what happens, generally speaking, is you get this big hype, and then the market corrects because we couldn't achieve the hype. And so what we see now instead, if you look across brochures and advertising and notes from all the folks out there in networking, we talk a little less about SDN. Actually, we talk a lot less about SDN now, and instead you see the word network automation. And so fundamentally, it's not about making the whole network SDN, but it's about finding more manageable, concrete initiatives to apply automation at the network level. And we've been doing that. It's not really new, right? But we've tied the ideas that we have from working through SDN and NFV, and we brought them to network automation, or we've evolved network automation to include these ideas as well. But fundamentally, what we find with network automation projects, unlike the SDN projects, is generally speaking, if you do it right, it's a smaller goals, smaller scope, and you get time to value much faster. And so that allows you to continually get more investment into the project and becomes a positive self-fulfilling prophecy in that light. And so what we see now is people working on initiatives to provision new networks, right, as you're building out your network, and to configure or reconfigure those networks. And to do that, not just based on rules and programmatic steps, but to do that taking a page from what we've learned with SDN and intent-based networking and the like, but to do a declarative control system for automation that is more scalable and easier to police, right, so to speak. And so generally speaking, that's what we see in terms of the evolution to a network automation approach to improving our networks. And then obviously, folding in, and we understand this now, the importance of telemetry and monitoring to make sure that those networks are in compliance. The fact you configured them yesterday doesn't mean that they're still configured the same way today. And so that monitoring, that compliance monitoring, the drift, drift detection, things like that are now all part of network automation. And so we've moved from, the venerable OpenFlow standard, the protocol that that was really hard, but we've learned a lot more now. It's now about netcom yang, about models, about OpenConfig, about, in many cases, RESTful APIs on our networking equipment. And there's a lot of efforts around models and abstractions, and OpenConfig remains a important thing, for instance, in terms of the overall evolution of the network automation market. And so, again, right, I mean, collectively, we all said a lot of positive things about SDN. And I think across the board, I think everyone's realizing that network automation is positive too, but I think you will see some somewhat more muted promises and predictions from the analyst community, including everything. So, but if you look at the market growth, ACG is talking about an annual growth of about 30%, and a lot of respondents are looking to achieve significant automation over the next 5 years. And the friends of Futurium in the survey talking about the goals of network automation are very basic business goals, right, that they're trying to achieve. And a lot of it is about time to market, flexibility, agility, and certainly operational cost and capital reduction goals, but they tend to be secondary goals. And so I think we've learned our lessons over the last 7 years with the whole SDN, white box and all that shift, right? And the positive thing about network automation is in Itential sponsored survey that EMA did, independent survey, they found that over 91%, they reached out to 250 organizations who had implemented network automation, that 91% of them actually had positive improvement. And so that actually is a resounding success, or it's resounding support for the promises of network automation. And I think, with statistics like this, I believe that network automation is a lot more real than what we talked about, and has value. And so, maybe at this moment, I'll turn it over to Chris briefly to talk about, that hype cycle, right? The market correction that we saw with SDN, and what his view of network automation and the hype cycle is in networking. Chris?
Thanks, Roy. So when we look at network automation, we really consider it at the intersection of a number of different technology domains. And a lot of the verbiage and acronyms you'll see on this chart are traditionally thought of as either attached to the networking domain or attached to maybe network management platforms. But a lot of our customers and the market, I don't want to say it's confusing, but we're at the intersection of these domains where it's helpful to think of these technologies in the context of how they'll support your network automation strategy, and think about where they are in their progression. So some of the technologies that Roy spoke about, like SDN and NFV, have been around for quite a while, but they've tended to slow down in their natural state. So kind of abstract concepts of deploying SDN control or virtualization that's agnostic to a specific deployment. But you'll see things like SD-WAN, which is a particular solution based on SDN and NFV concepts, kind of spit out the other side. So as we talk through today, we think it's useful to put some context around a lot of the technologies and or vendors and or open source initiatives, and talk about how these all fit into a pragmatic approach. Obviously, we like sitting around talking about some of the most interesting technology and advancements, but the reality is, as we look to deploying automation in the field, and as we look to building software platforms to accelerate that automation, it's critical that we figure out where they are on their cycle, and we make sure that we're adopting the right technology for the right job. So with that, I'll let you keep going, Roy.
All right, well, thank you, Chris. Appreciate the perspective. And so certainly network automation, we're looking at it a positive light, and there's a lot of promises that we think this time can be fulfilled. And in fact, those who have implemented it are indicating that, yes, they are getting benefits from it. That doesn't mean that it's easy. That doesn't mean that it's not challenging. And so in conversations with enterprises and service providers, what we've heard from them in terms of issues or blockers in network automation include things like poor scoping. Some of us haven't learned the lesson of not trying to boil the ocean when we implement network automation, and instead of trying to take on the entire network or to try to take on 10,000 nodes at one time, pick a small subset of the network to automate. Pick simple goals. And so that's certainly one of the challenges. The other one that's actually very common is lack of resources. And I don't think that's going to go away. That's just reality. Lack of resources in terms of people, skills, and capital investment. But the nice thing I think about network automation is that it can be quite incremental, and it can leverage existing skills. And it demands a little less, I think, from the team than a full scale, SDN or NFV rollout. And so certainly, I think there's likely more chance of success in overcoming the lack of resource challenge. Beyond that, we'll always have the vendor interoperability challenge. And for automation, it's not about everyone supporting SDN or the same version of OpenFlow or the like, but in some vendor situations, not all the features are exposed. So something that you want to automate may not be automatable, or the parameters may be limited in terms of what you can automate, or there may be some constraints. And so that continues, and understanding the capabilities of the different equipment from different vendors, that's still an important aspect of successful network automation. And along with that, or aligned with that, is lack of a common model. To get configuration consistency or model consistency, not all equipment will basically have the same so-called abstraction model for a particular network service. And while open config and the vendors involved in that are trying to move towards common models for many things that you're trying to automate, it's still going to be a work in progress. And then looking beyond those things, there are other aspects, which is, for network automation, yeah, certainly you can get by with some basic scripting or borrow some stuff from DevOps, but the tool and platform sophistication is in the process of getting better. And Chris will talk a little bit about that, and that's one of his areas of expertise, certainly. And then beyond that, scaling challenges. You've successfully automated 5 devices, 10 devices. Doesn't mean that the same framework, will support 1,000 or 10,000 devices. And then finally, when you get to more advanced network automation and trying to use telemetry information, monitoring information to direct the equipment, or to, run or to influence the behavior of your network automation. You may find that the key statistics are not available, so you can't do a complete closed loop process, or that the telemetry, is not at the granularity that you would like. And so there are some situations where you run into the unavailability of information that you may need for successful network automation. But these challenges can be overcome if you take the right approach. And if you succeed, you can apply network automation across the board, right? So again, it's not limited to the WAN or data center. The reality is network automation can be applied across private clouds and public clouds. You can script and control things in VPCs, virtual private clouds, and public clouds, and campus networks, branch networks, mobile networks. So again, value to both service providers and enterprises alike, and cloud providers as well. And all domains, right, from layer 2 to layer 7, there is value in there. But again, it comes down to understanding, how you structure that. And to talk about, how you can go about that, a real world pragmatic approach to network automation, I'm going to turn it over to Chris. Chris?
Thanks, Roy. I just wanted to start off by talking about pragmatism. And we're going to talk a lot about practical approaches today, but I don't want anyone to think that practicality takes away from being part of your long-term strategic initiatives. There's a lot of discussion around network automation with machine learning and AI concepts. And much like SDN and NFV, we like to jump to maybe some of the more robust problems to solve. But we think we have a lot of steps and building blocks to kind of build the network automation strategy that you can build the foundation that we can start to do some of those innovative things on top. So when we're talking through the topics of today, we don't think that any of this leads you towards any sort of cul-de-sac or anything that we're going to do doesn't lead towards your long-term strategy. So I thought it was important as we talk about practicality to not think that it's anything other than supporting all the strategic technology advancements that we've come to know and love as we talk about the future of modern networks. So if we think about the steps, and I'll just go left to right here, of taking an approach, we think the first thing to start with is the use case. A lot of times we talk about network operating systems, or we talk about a specific domain, which we'll talk about in a minute, but we do think starting with use cases, and we do think that the innovation cycle can start in kind of 4 main buckets. So a lot of customers start with operations activities, software upgrades, basic configs, not necessarily multi-device service orchestration or cloud policy. But as you see your use cases stack up, you can start with something simple like operations and maintenance. That can lead you into device-specific configuration. And then as you become advanced and you feel comfortable with automating device configuration and some of your device lifecycle activities, we can step up to service orchestration and ultimately policy. And we think policy is really abstracted from the nature of the network and the specific domain that we're going to get into. So we like to boil down network activities and network management plane changes into those 4 buckets, and we think it makes a lot of sense for our customers. Now, how do we apply those use cases to specific domains? They kind of are different. So if you're looking in physical infrastructure, if you have a branch or you have a data center switch, those are physical devices. If you're looking to the cloud, or if we're looking to some of the advanced SDWAN components, then they don't have a physical device. We start working with virtual devices. But if we apply those use cases to a specific domain, kind of the intersection of those two really drive out specific use cases with specific benefits. And notice we haven't talked about necessarily any of the technologies that we had within the maturity curve earlier, but defining your use case and defining which domain you want to apply those use cases to is a great place to start. So after we have our use case and our domain, a lot of times we need to talk about the sources of truth. So what we mean by that is historically, we tried to centralize everything either in a CMDB or an inventory platform. And the reality is today, the network is more distributed than ever, especially when you have multiple domains that make up your network. And that source of truth is going to be both highly distributed and it's also going to be highly fragmented. So when you think about automation, we think it's critically important that we think of using the source of truth, which is the most accurate for the use case and the domain that we're trying to achieve. So that might be an IPAM system. If you have adopted SDN concepts, so maybe you have some controllers or orchestrators in place, or maybe you have some cloud platforms like AWS or Azure, you're going to need to have real-time access to those platforms to determine what the truth is right now. Historically, we've made spreadsheets and we've taken copies of databases. And for networks that were fairly static, that was enough because I could assume that an IP address that was applied to a branch did not change. In today's world with the velocity of network services growing, I can't make that assumption, especially when I've put controllers or orchestrators in place that might make changes on the fly depending upon what's happening in the network. So determining and understanding which of those sources of truth tie back to the use cases and domains that we're attacking first is critical. And then based on those sources of truth, we're going to need to build integrations with each of those systems. I think the good news is that vendors, both on the network side, the IT side, and your cloud SaaS type of providers are all building very robust integrations today. So the integration tax that we've had historically, we think is being torn down. So being able to integrate, either leveraging your DevOps platforms or direct integrations, most are providing REST APIs with either under the open config banner or otherwise allow us to accelerate building those integrations, and we'll talk about that later. And then the last thing is really understanding who's going to do what within these systems. When we think about the evolution of network automation, a lot of times we start with scripts, and a lot of times those scripts are on a disk somewhere, and I might have to have file access to execute that. Now, once we start to automate the network, and once we're integrating with these other systems, and I expose them through APIs, the people that can execute these are now remote, either machines or other groups within the system. So applying group-based access control and understanding how I tie this into either my LDAP or other execution means becomes critically important, because we've moved changing the network from a CLI and file restriction type of basis to now APIs open to the ecosystem. So when we start thinking about advanced automation concepts, very quickly people move to not just security, but the ability to make any change within the network and exposing it through an API both provides a lot of value to the business, but also we need to address who and how people can execute that. So as we look at the different domains involved, we talk about starting with the end in mind. In most instances, you're going to focus on a domain or two. In most instances, you're going to start with the technology that is most widely deployed within your enterprise or service provider, and where you can add the most immediate impact and prove that incremental automation is going to provide value to the business, so we can be more aggressive. But at the same time, as we start, we do want to think about the long-term evolution of our automation strategy, which is going to traverse multiple domains. So if we talk about the use cases that we started with, we talked about starting with operations and maintenance, maybe moving into device lifecycle, and then moving up into service and policy. We'll look at a use case here in a minute, but a lot of these use cases and solutions that are rolled out today traverse multiple domains. And we want to think about solving them at the domain specific layer, but also how are these pieces going to fit together. So the types of controllers and automation concepts that I have within a wireless domain, maybe whether it's Wi-Fi or service provider wireless, is very germane to automating wireless infrastructure. If I'm looking at a cloud or a branch, there's very specific either technologies or APIs or modeling concepts that are specific to those domains. So part of being pragmatic and practical is breaking down the larger problem into these domain specific attributes, but we also want to think about how we put the building blocks together later. And because of the robust APIs that exist, your technology choices and your automation choices within these domains have APIs to fit into your larger end-to-end automation platform. And if you think on the north side of this diagram, you're also going to be integrating this into your IT system so that your IT systems can have more of a network API that allows you to expose these network automation concepts into the rest of your business and ultimately provide self-service portal to your end customers. So we're talking very much about domain-specific concepts, but we can understand how these will be tied together, and we can understand how they'll be integrated with the rest of the business so that you can get the true value from the investment you're making. So maybe just to take a step back and talk about how, Roy was talking about how SD and NFV concepts have been talked about for a few years and how it is pretty dramatic change from how we were managing devices. So in today's world, even when we talk about network automation, people think of a device as a device. And what I mean by that is that, you have some hardware that's depicted there on the right-hand side, and then it has an operating system deployed on it. So whether you're buying traditional equipment vendors stuff, or whether you're seeing some white box stuff with some open source Linux-based OS on it, on the left-hand side, this is just a snapshot of some config, and it's dependent and it's very specific to the operating system that you choose. And we think one of the issues with automation is we have to manage all that config, and a device might have 2, 3, 5,000, 10,000 lines of config. And all those config items are thought of as the same. But if we want to start talking about automation and think back to the use cases I spoke of earlier, if I'm just doing maintenance activities, I'm doing a software upgrade, I'm really only concerned with that operating system, and it doesn't necessarily pertain to specific lines of config or code. But if I think about maybe doing my day 0 or day 1 config, which is specific to maybe how I do zero touch provisioning, or how I turn up a brand new switch in the data center, or how I upgrade a branch router. These day 0 and day 1 configs are specific to both the domain that I'm trying to automate, as well as a particular type of device in the network. And if we want to talk about automating, the box and the lines of config aren't as homogeneous. It's not just a long list of config. Each of these lines of config pertains to a specific type of automation. So day 0 and day 1, as an example, don't change with a service that I'm provisioning on it. So these would be specific to the device, maybe its location in the network, maybe its role in the network. And then what would happen on top is I might provision some services. So on the left-hand side, you can see service A and B, and that's some interface configuration that's specific to a type of service. So if I start managing my service lifecycle and service A and service B go away, there might not be any impact on day 0 or day 1. Or if I want to do config drift and I want to understand how my device maintains its golden config attributes, maybe I run the report and make sure that the day 0 and day 1 doesn't change, but I wouldn't run it on necessarily the services, because those are have a different life cycle. So when we start thinking about how we're going to automate the network, I think it's interesting for people to think about automating network changes at the device or service layer, but not necessarily thinking about it on a device by device basis. And I think this really starts to get into how are we programming the network, and how do we think of programming concepts rather than copy and paste and snapshots and restoration in a box by box basis that we've done in the past. So if we think about the skill sets needed to achieve automation, and Roy mentioned this earlier as one of the challenges of adopting the frameworks, are that what we've heard in the marketplace is that we need to have and cross-train resources, and we need everybody to understand all of these concepts to be successful in network automation. So that means you need to understand network engineering. We need to understand how some software development capabilities, and then we're seeing the rise of DevOps tools and platforms, either as the basis of using DevOps platforms to push configs to the network, or ultimately moving CI/CD as the method by which we make changes in the network. So a lot of new skill sets around DevOps, a lot of knowledge around networking and how we make changes to the network, and then augmenting that with some development capabilities, whether it's scripting or programming, to achieve some of these network automation concepts. And ultimately, there's not a large pool of resources that can do all of these things. So we think it's very important that the tools that you choose increase the level of participation from your entire organization. Something we've learned very clearly is it takes a lot of people with a lot of skill sets working together as you go on your network automation journey. And rather than trying to have a small number of people with all the skill sets, we think anybody with any of these individual skill sets can participate in the way that in the most meaningful way. So having network engineering concepts, having some people who can do scripting and development, and having people that understand DevOps platforms, the types of tooling and platforms that we think you should be looking at are platforms that engage each of these roles and each of these people in the most appropriate way so they can participate. Because ultimately the largest volume of participation is going to equate to the success of your network automation journey. And waiting to cross-train everybody to have the full set of skills has been less successful in the sense that it's constrained everybody's ability to participate and move the ball forward. So I'm going to walk through two use cases. The first one is SD-WAN. And on the left-hand side, there's that drawing there that comes from kind of the network automation domains we had before. So when we think about an SD-WAN deployment, and there's a lot of discussion of SD-WAN 2.0 or 3.0 within the marketplace, where we started with MPLS circuits that were expensive, and we wanted to be able to route traffic over cheaper internet routes for when people were searching, Facebook and the news, and we wanted to put the critical traffic, business traffic over your MPLS network so we could divert some of the cost of growing bandwidth needs at the branch. And if we look at that ecosystem and the vendors that are participating, they're innovating at such a clip that this is no longer the basis for just deploying SD-WAN. We have all the benefits of direct connect into cloud platforms. More and more today, we're using networking services that are within the cloud. So, a SD-WAN deployment, which started off as maybe refreshing your branch and having both a dual MPLS and internet link, has now turned into a hybrid cloud and as a service type of offering. And what people are realizing is that this is more complex than originally stated. And we think about what should we do? We go back through kind of the pragmatic steps. We talk about, which use cases do we want to deploy? So I need to deploy a new branch. What types of activities do I want to automate? Where are the sources of truth? And then ultimately, how do we roll this out in a way without being too disruptive? So thinking about SD-WAN as a use case starts off quite small, but you can see how it becomes a multi-domain problem pretty quickly. So we want to take kind of the deployment of that new SD-WAN branch and break it down into its constituents parts, whether it's the branch component, your data center component, or your cloud component. So maybe a second one to talk about is a network application. So a lot of times we think about networks pertaining to routers and switches, but where we've seen a lot of success is with customers looking at load balancers, firewalls, a lot of times considered middle boxes. So when we think about network applications, these are highly programmable network elements. So the use case I was talking about before with breaking down the device config of routing and switching, I think some of these vendors, because they are more application centric, are farther along providing direct REST APIs, and these are fairly foundational. But where this might be a practical place to start is that while these are more simple from a programmable concept, the value to the business is a lot of times people roll out network services, but maybe updating an ACL, rolling out a firewall rule, or updating the load balancer might be, from a interval perspective, the biggest inhibitor to rolling out new applications. So something that's already fairly programmable at the network service layer is an opportune place to drive a lot of value. And something we've seen with our customers is that once you make this programmable and you expose it within an API, this is an ideal candidate for some of your self-service concepts, which we think is the ultimate goal for network automation is to allow the business to have an API that directly allows them to manipulate the network with obviously the constraints that we talked about before. So once you make this programmable, you will actually see the use of these network applications increase because we've taken it from maybe 2 to 5 days down to instantaneous. And the fact of the matter is it kind of proves that the network is a constrained resource, and it shows that once we make it programmable and once we wrap our network in automation, the business is going to get more benefit from this, and they're actually going to use the network more, much like we've learned from our public cloud partners. So just a bit on how Itential focuses on each of these steps within this pragmatic approach. So these are the 5 same steps that we talked about before. So I'll talk a little less about each one and maybe just around what we think, how Itential can support each of these steps as you go on your network automation journey. So when it comes to defining use cases, we do have a developer site, and we've been putting sample artifacts. We think it's important that we not only describe how to automate the network, but provide sample artifacts of how other customers are doing it and creating a community. You've seen this with some of the large equipment providers as well, where you're seeing a lot of pushing out of sample automations so that people can get started more rapidly. The second is those domain specific focuses. So the 8 domains that we talked about before, having specific and targeted KPIs as well as samples back to the artifacts for each of those 4 domains: maintenance, config, service, and policy across each of those domains, whether it's data center, cloud, SD-WAN, branch, etc. And then the next 2 is really around getting the source of truth and integrating with the rest of your IT and SaaS ecosystem. And we've been working very hard on the commoditization of all of these APIs. So when you think about all of either your network choices, your multi-vendor choice, your controller choice, your cloud choice, your branch choice, a lot of what we consider the modern network is providing robust APIs. And we're both open sourcing our library of adapters so that the cost of integration gets driven down, but also providing a way for you to auto-generate these adapters. So we think this is fairly unique in the sense that you can upload an open API spec or maybe a Postman collection and auto-generate an adapter. But we think the rest of the market and the rest of the industry will continue to drive this so that you as a network engineer and network operations team can feel that you can adopt network automation tools. You can have your choice of equipment, and you can also have your choice of IT and cloud partnerships, and you can focus on the actual network automation and be less concerned with which systems connect to which systems and having the inhibitor be any sort of integration tax. And then ultimately, our platform ties into your choice of LDAP or AD system so that you can use your existing group-based access control, and you can apply that either through that self-service concept or in how you want to allow and enable the rest of your organization to integrate and drive automation concepts. Maybe just tying back to one of the first things I said and then handing it back to Roy is that as we think about kind of pragmatism and as we think about how to automate the network, breaking down use cases and market segments into device concepts, and which systems we're going to integrate with, we think some of these foundational concepts move back and tie into your long-term strategic focus. So we think DevOps concepts, either from a skill set perspective or from a tooling perspective, are key. The long-term focus on that is running the network as code. So running from a Git repo all the way down into the network. That's quite a bit to take on at once, but as we build towards that strategic focus, focusing on the entire DevOps lifecycle is going to be key. We talked a lot about going from the domain strategy, supporting your multi-domain and end-to-end concept. We do think a lot of people focus on execution as it pertains to network automation, and we really need to look at the end-to-end process and the multiple domains that are incorporated. And then those sources of truth tying into your federated distributed system. So it's for when you start to expand your use cases, the number of sources of truth can explode quite quickly. So as we pick those use cases, I think it's critical that we think about where we're getting the data and how we're getting it, with the understanding that the system is only going to continue to become more and more distributed. So not taking copies of data and planning for a world that is federated, we think is key. And then everybody is already on the journey from going from your data center and single cloud concepts to a multi-cloud strategy. And then the last one, which I don't think we really hit on too much on this webinar, is the fact that when you're doing network automation, you're going to have places where you're going to need to have some human-driven fallout, whether that's a chat out to a network engineering team or whether you need to put in some non-machine steps. It's okay to start slow, and it's okay to have incremental progress towards your automation. And if we look at typical processes, starting with an end-to-end automation, having 5 or 6 steps for human-driven fallout, over time, as we connect to higher quality pieces of data, or as Roy said, maybe we hook up into telemetry systems, and maybe you don't have that today. Maybe a human has to make the decision that can be replaced by some telemetry or real-time data in the future, will lead us towards that end goal of having a closed loop in RPA. So on the right-hand side, the strategic focus, you really see a lot of the words that we see from both a market perspective and kind of longer term vision, but focusing on some automation concepts and putting the building blocks in place, we can use to get there. So maybe Roy, I'll turn it back over to you to talk about the stages down there below.
Yeah, certainly. So I think, as we talk about, Chris has talked about sort of laying the pragmatic foundation, and how do you relate that to the appropriate strategic focus. And what we see in terms of abstracting the evolution of network automation over time is, a lot of the organizations that we work with, I speak to, they start with something very basic like ad hoc scripting, right? That's usually how they start. Oh, let's just put a little script in place so I can do this a little faster the next time. And then over time, this is natural. It evolves and builds up a set of libraries and components, and they're like, oh, we're reusing this one, or this is reusable, or and then they realize, from looking at different patterns, that certain elements of those are in fact reusable, and then they build those libraries, and then they start taking that and creating a rule-driven automation framework with a bunch of templates, and then they recognize that a rule-driven approach may not be as ideal in terms of scaling, in terms of consistency, and so then they go to a more model-driven network, a model-driven framework. And so this is sort of the mirror of that intent base, right? Basically, to say, look, I would like to configure connectivity from this location to this location, and here are all the devices in between, and here are the models of these devices, and then regardless of which vendor they're coming from or what the specific interfaces are, that the system is smart enough to deal with it, right? And that's sort of another level of abstraction that makes life easier for the network engineers and network architects. And once you get beyond that, then you can look at things like closed loop. Reality is you could probably add closed loop earlier than that, but they would be more technical, they would be more compartmentalized. But then once you get to a certain level of sophistication, you can start using information coming in and having the system automatically do the right thing, optimizing the network or taking into account failures and routing around those failures, or dealing with it appropriately. And then from there, what we're seeing is using AI and machine learning to assist in network optimization, network automation as well, where you have a certain amount of intelligence, and they notice that every time a human does this, based on these events, I could probably automate that as well. And so then you get to AI assisted or AI ops over time. But that's all very laudable in terms of that sort of the vision and getting it there. But the reality that we see is that a lot of organizations, and this, based on the EMA survey, was that, most of those who have implemented network automation are still, in the ad hoc side of the equation. And very, very, very few on AI based, and so Not surprising because it requires a certain level of sophistication to get there. And so when you look at, what's happening out there, people still need to understand how to take the first few steps or how to go beyond very basic, scripts that they may have lying around. And I think, what Itential and Chris have done is laid out, how you can take a pragmatic approach, how if you have to write model and framework in mind, that pragmatic, small incremental step approach can be strategic. It can take you down a strategic path, that doesn't require throwaway or substantial rework, but in fact, you can build little pieces that actually can be the foundation of building towards a large scale network automation strategy. And so that's certainly something that I found really helpful today and hope you did likewise. Any closing words, Chris, before we move on to Q&A?
No, I think maybe just the Q&A, given the time.
Oh, excellent. Let's do that. At this point, I'd like to encourage the audience to go ahead and ask the questions. You are welcome, to just type it into the Q&A window in there. And if for whatever reason we're not able to get to your questions today, we, Itential can reach out to you directly and assist you with those queries. So again, go ahead and please ask those questions. Now, let's take a look at incoming, and we'll go ahead. So speaking of pragmatic perspective or pragmatic approach, what use cases do you advise starting with?
So I think we really broke it down to those four. I think that a lot of people, it depends on the type of domain they're really focused on. So if people have an orchestration product or a controller product in place, then it's great to leverage those to start doing some more advanced concepts. If people are doing more device-centric CLI automation and they're working with maybe scripts today, or maybe leveraging a DevOps tool like an Ansible or a SaltStack, then a lot of those folks could really benefit from focusing on the maintenance activities and some of the operations concepts. And I think saw another question down here about it, but looking at the end-to-end processes for human-heavy maintenance operations, config management concepts is a great place to start and shows a lot of benefit out of the gate.
Mm-hmm. Got it. Oh, that I would agree. That's very good. And then this one, I think this had to do with the getting started. And you talk about pragmatism. And this question, the questioner says, we've had an automation initiative for several months now. Not surprising, we see a lot of that, but still haven't kicked off the project. Again, not surprising. What action can I take to remedy this?
So I guess I'll answer it two ways, not understanding which one they're talking about. But from a business perspective, we do see everybody understands they need to perform some automation concepts, tying that back to what is the benefit. We see a lot of folks talking about they have actually more maintenance activities than they have during maintenance windows. That's one. So it might be looking at the effort it takes to do the daily activities on the network. I see a lot from the DevOps community talking about, taking the amount of work continues to grow, but trying to maintain that in a reasonable effort. The part that I think is maybe usually missed more is the fact of cycle time and the fact that time to market on changes. As we look at, larger transformational programs, the network is a lot of times thought of as the kind of the critical path or the part that holds up some of these deployments. So really taking some of these cycle times on brand new introduction from days to minutes is a really big deal. So I think on one side we kind of have the human driven effort cost, and on the other side we have kind of the time to market or the time to deployment. So that people can use their in-house network infrastructure and not feel like they have to jump out to a cloud provider to get services deployed in a reasonable amount of time.
Got it. Excellent. All right, let's move on to the next question here. And the questioner says, in network automation, can we use cognitive machine language APIs to help with intelligent network provisioning and integration? And could this help make the system more proactive in terms of fault tolerance?
So I love talking about machine learning concepts for sure. I think some of us are jumping from, if we have a network today that is very CLI and human driven, and we want to apply machine learning concepts to that, I think we're kind of jumping over multiple steps. So I think having processes and automations that we can actually write machine learning concepts on top of would actually allow us to introduce this type of technology on top of programmable infrastructure. So as I think the introduction of those concepts is very much locked into when the network is very programmable. So in this phase where we're in between and we're putting programmable concepts on top of physical infrastructure, and as the network becomes more programmable, I think we need to focus on building a level of programmability so that we can actually build some of those ML concepts on top. But as we stop the snowflake effect and as we build more standardization into the network, there's no doubt if we're doing changes at a high clip, hundreds and thousands of times, then over time, the machine's going to be able to figure out the anomalies that today are driven by advanced engineering and operations teams.
Got it. Yep, I think that's fair enough. Again, right, taking the pragmatic approach. Yeah, I'm going to combine two questions here that are similar. The one has to do with, I think we talked just now about unblocking some of the, getting past the I've got an initiative, but I can't get it started issue. This one I think has to do with a lot of people are in the stage where they have a bunch of scripts. And how do you move into sort of the rule-based approach, which I view as sort of, the templatized or template-driven element. And if you could maybe provide some ideas on what you've seen in terms of organizations moving from one stage to the next, which I think is a significant step. I think that would be helpful.
Yeah, I think when we first started automating on top of the network, even back in the days of Perl, we would build scripting that would automate things that I would do. So it's the benefit to me was that I could skip the manual intervention and automate what I was doing. As we've moved into some more libraries, and most people are using kind of Python concepts today, for me to share that with my peers, we had to start thinking about introducing templates and stuff that wasn't just Chris's script, but was a rule-driven or template-driven framework that I could share and have a community around. So, whether it's the best or not could be debated, but I think in today's world, a lot of Python and a lot of Jinja templates and a lot of text FSM templates allow us to share within the community that's specific to device frameworks. And although it might not be models directly, those templating concepts paired with variabilization allow us to make that interim step and more of a rule-driven, template-centric approach, so that we can kind of make progress as we move towards more, the model-driven concepts, whether it's Yang or Tosca and some other cloud-driven components.
Got it. I appreciate it, and hopefully that answers that question. At this point, actually, we're at the top of the hour. I know that there's still a couple of questions here that we did not get to, but Itential will be able to reach out to you on that. And with that, I'd like to thank all of you for having been with us the last hour. Hopefully you found it pretty useful, and I know I did. And hopefully you'll find a way to take the next step in your network automation journey. With that, I'd like to thank Chris from Itential in sponsoring today's webinar. And again, I wish everyone a good day. The recording will be available shortly. For those of you who have friends who signed up but couldn't make it, please let them know once it's available. And hopefully they find it helpful as well. Bye for now.
Thank you.